Okay, so I'm going to explain today how a Ethernet broadcast domain works. Now, we all know what an ARP request is. This PC wants to find out what is the MAC address of this IP address. Now, in order to do that, it needs to ask all the devices on the network and ask, hey, does anybody have this IP address? Now, what it needs to do is it needs to send this message to all the devices, to the laptop, to the printer, to the phone. But there's a problem. There's a rule that states that there needs to be a source MAC address and there needs to be a destination MAC address. But again, we do not know the MAC address. So what it can do, it can now send multiple messages to each MAC address. But the problem is we'll miss out on the one that doesn't. So there's a MAC address, a special kind of MAC address called the Ethernet broadcast domain, which is used as the destination MAC address. So then this data packet will have the destination MAC of FF. Now this tells the switch forward the data packet to all the devices on the network, to that device, that device, that device. Then this device will take a look at the IP address and sees that it does not match, so it rejects the message. Then the laptop will do the same, reject it as well because it does not match. But the printer though, the printer will look at its IP address and see, hey, I match with that IP. Then what it will do is it will respond with an ARP response and tell it, hey, I have this IP. And when that is done, the PC will finally know the printer's IP MAC address. Now, so the only way this conversation was made possible was because we used a broadcast. Broadcast means one device sends a data packet to all the devices on the network. And this was also possible because we used a specific kind of Ethernet, a specific kind of MAC address, a Ethernet broadcast domain, which is FF.